Hello, my name is Miss View, and today we're going to do an assessment review on expressions and equations. So we'll be looking at using properties of operations to generate equivalent expressions. So you've learned many different standards throughout the school year. So there are several standards that we really want to make sure that you get a good grasp on because you're going to need them next year, the year after that, and the year after that. So one of them is understanding that rewriting an expression in different forms in a problem context can shed light on the problem and how the quantities in it are related. So let's get started. Okay, let's get started. Which expression is not equivalent to the other three? Okay, so when we're tackling a question like this, the first thing I'd have my eye on is not equivalent. Okay, so sometimes we're so tempted to pick that answer that's correct, but in this case, we actually want the one that's not correct. Okay, so beware. Let's go. So what I would do is I'd actually start simplifying the questions, and then that way I can see who's equivalent. So let's start with A. A says 5W minus 18W plus 6. Is it solved? Is there anything else I can do? Great job. What we can do is go ahead and combine like terms. So you notice 5W and negative 18W are like terms. So we can go ahead and simplify that. So 5 is a positive number. The 18 is a negative number. So remember, you're doing 5 minus 18. And that will give you negative 13W. Okay? And what's left over? My plus 6. I can't put 6 with 13W because they're not like terms. All right? So let's look at the next one. We have negative 3 parentheses 6W plus 2 parentheses plus 5W. All right, so what would be the first step here? Oh, good job. We got to remember our PEMDAS. So let's see. We've got parentheses, but 6W plus 2, we can't do that. So what can I do? Great job. Distributive property. So we can do the negative 3 times 6, and that would give you negative 18W. And we can also do the negative 3, negative 3 times 2, and that would give you negative 6. And then we also have our plus 5W. Are we done? Not at all. We can actually still combine like terms. We have a negative 18W and we have a 5W. So negative 18 plus 5, that gives us negative 13W. And what's left? Minus 6. Okay? Negative 13W minus 6. Ooh, I've already noticed something. B and B are the same. But before I get excited and assume that A is the wrong answer, always go through just in case. You might have done an error with your arithmetic. So let's check out C. We've got negative 18W minus 6 plus 5W. Again, we want to combine our like terms. Negative 18W plus 5, we've already discussed, gives us negative 13W. And what's left over? Minus 6. Hooray! So A was the incorrect answer. Great job, guys. Okay, for this next question, it says, which expression is equivalent to g minus 0.75 g? Ooh, they just give me one number? What's g? I don't see a number in front of g. Does that mean anything? Yep, you're right. That simply means there's a 1 here. So in algebra, they don't like to put the 1. But you just have to know if you see a variable and no number, it always means 1. Okay? So I put 1 there just because it's easier on your eyes. Okay, so now we have 1g minus 0.75g. So what can I do? Yep, you're right. I can actually combine them. So we can do 1g minus 0.75g. So you can solve it as decimals, but if you think about it, 0.75, that's one of those numbers you should automatically know, okay? Think of it as 75 cents. So $1 minus 75 cents would leave me with what? Yep, 0.25, a quarter. So my answer would be 0.25g. Okay? So let's see. Oh, my little point didn't show. There we go. Those don't quite look like my answer. So let's go through them. A says 0.25 less than G. Is that what that means? Nope, not that one. 0.75 times G? No, that's what this part of the question looked like. So that's not it. 0.25 times G? Absolutely. C is our answer, okay? Remember, when you have that number in front of the letter and no symbol in between, that automatically means multiplication. That means times, okay? Must remember that. Very good. Next question. Okay, so this question says we're going to select all the expressions that are equivalent to each other. Okay, so once again, we're going to simplify each one of these expressions. So let's get started. With this first one, 12 plus 3x. Anything else I can do? Nope, that's as low as we can go. Nothing to do there. Let's check out the next one. We have 3 parenthesis 4 plus 4x minus 3y parenthesis. Yep, we can definitely simplify that one. So we'll do our 3 times 4, which is 12. Then our 3 plus 4x, which is plus 12x. And then our 3 times negative 3, which is negative 9y. Awesome. Okay. Can I do anything else? Maybe I can put that 12x and that 9y together? No, we can't. Okay? They are not the same. They are not like terms. So that is as low as you can go. So let's try the next question. Again, we've got a 3 parenthesis 4 plus 3x. And we're going to add that to a 3 parenthesis x minus 3y. So let's get started. So we'll do 3 plus 4. I tried to catch you. Nope, we do 3 times 4. Good, that's 12, multiplication. Continue the distributive property, and we've got 3 times 3. So that gives us 9x, okay? Never forget the variable. For this next one, we have 3 times negative 3y. So we'll write negative 9y. Oops, it looks like I skipped one. Let me erase this. Before I get to the 9y, I forgot about my little 3 over here. So we're going to put plus 3x. Now I can go ahead and put my 9y. Okay? So always remember, when you see that variable with no number in front of it, there really is a number. It's a 1. Okay? All right. Am I done now? No, we can continue simplifying. So we've got 9x plus 3x. They're in the same family. They're like terms. So we've got 12 plus 12x minus 9y. Ah, I'm already seeing something. Yay! B and C are looking the same. But let's continue going just in case. So we have our 3 times 4, which is 12. And then we have our 3 times negative 1. Okay, that's what you see in front of that x. It's invisible. And that gives you a negative 3x. So, where are my equivalent expressions? Yep, B and C. Those would be our answers. Yay! They're the ones that are the same. Okay. Okay, so we have a pool that is 25 feet long and 10 feet wide. The length and width of the pool will be increased by the same number of feet. This expression represents the perimeter of the larger pool. X plus 25, x plus 10, x plus 25, x plus 10. Which expression is equivalent to the expression for the perimeter of the larger pool? Okay, so let's see. We have, let me try to write as small as possible, x plus 25 plus x plus 10 plus x plus 25. Whoops. Erase that. Plus x plus 10. Excuse my challenging handwriting and trying to make sure we have enough space here. Okay, so the first thing I'm tempted to do is combine all these like terms, right? So the normal numbers and the variables. So how many x's do I have? Yep, 4 x's. Plus 25 plus 10 plus 25 plus another 10 gives us 70. Ooh. So let's see. So far, I like C. Next, let's see. Do anything else looks the same? Let's head over here and see. We've got 2 times 2 is 4x. 2 times 35, that's 70. Yep, you can pick that one. I already know there is no way B can be an answer because that's going to give us a quadratic. So nope, we can cross that out. I don't think you guys learned that yet in the 7th grade. So now looking at D, let's see what we have. We've got 2x. Using my distributive property here, plus 50 plus 2x plus 20. All right, so again, using my distributive property. So I'll combine my like terms. We've got 4x plus 70. Okay, yep, that one works. And again, looking at E, we already know that's going to be a quadratic. So I'm going to cross that one out. So there are your answers, A, C, and D. Awesome. Hooray! We did it! Yes, guys, I knew you can do it. Awesome. See you next time.